Thanks for joining today's webinar. I'm Tiffany Nichols, Marketing Director with Salt Security, and I'm joined by Nick Rago, Field CTO at Salt Security. API attacks aren't like traditional application attacks. Understanding those differences is crucial to protecting the valuable data and services your APIs enable. I'm now going to turn it over to Nick to discuss the changing nature of API attacks and share some best practices to keep your organization safe. Welcome, Nick.
Great. Hey, thanks, Tiffany. Thanks for the introduction. Hello, everybody. Glad to be here. I'm Nick from Salt Security, as Tiffany said. Thanks for joining this digital event today. Wanted to do a few things on the event today and talk today more specifically about understanding API attacks, as Tiffany said, why they're different and how to stop them. Wanted to first talk a little bit about why we're even here in the first place talking about APIs. And it's no surprise to everybody at this point that we're living in an API-first world right now. As a result, API production, consumption is continuing to skyrocket, and APIs have become the backbone to today's digital economy, and they power nearly every aspect of modern applications that both businesses and consumers are relying on daily. So there's a lot to love about APIs. They've changed so much of the world, from interoperability and integration to rapid development and innovation, ecosystem expansion, microservice architectures has changed the way we scale, maintain, and manage applications, mobile web, cross-platform, data access, the digital economy. There's a lot to love when it comes to APIs. But as with all good, there is some bad. We're not alone, and APIs have taken on the admiration of other entities. So one of the things that we're seeing is whether it be to exfiltrate data, take control of critical systems, disrupt key business services or digital supply chains, threat actors have taken notice and view APIs as a new prosperous and ripe attack vector, and an attack vector with a relatively low barrier to breach. So it's no surprise that APIs have been top of mind to many security professionals today. And in Salt's recent State of the CISO report that we just released, 78% of CISOs are saying that they're prioritizing API security more highly than 2 years ago, and 95% of CISOs surveyed are saying that API security is a planned priority over the next 2 years. That's a major increase than we've seen over the last couple of years when we're talking and surveying CISOs. But even with API security top of mind, we're still seeing a lot of cyber criminals finding success with this particular attack vector. And there's a few different reasons for that. And it's important to know why adversaries are focusing their attention and their guns on APIs. One of the major reasons is that there are several security challenges that are associated with APIs that organizations are really struggling to get their arms around today. The first challenge has to do with this notion of API sprawl. Organizations have moved from a world where they had a few APIs, maybe for external facing and partner integrations. But as we moved into this and embraced this API first world, APIs are everywhere. They're microservices in our applications. What used to be back-end functions are now exposed as service units exposed to the outside world that make up a digital supply chain or business supply chain. We have third-party APIs in our organization. We have low-code, no-code systems that are publishing APIs in our environment. We have development teams in 5 different places using 5 different technologies, all working on one particular business function, a business service, with different APIs distributed in different ways. So this whole notion of understanding where are my APIs, what's the posture of the APIs, what type of data are associated with APIs is something that organizations have really, really been struggling with today. And getting in front of those APIs has been very, very difficult for organizations. And it seems like for a lot of organizations, that has been a daunting task. One of the other challenges with APIs has been the fact that they're changing frequently. So what I knew yesterday about my APIs and the posture of the APIs and what they're doing is maybe completely different today. Just recently, Salt released its API security, State of API Security report for Q1 2023. And one of the interesting data elements that came out of that report, or findings from that report, was that over half of the respondents have basically said that, listen, our APIs change monthly. Over a third of them said weekly, and almost 10% of respondents say API endpoints change daily. So think about that. I'm increasing this attack surface. I'm adding more and more APIs with more and more functionality every day. But the APIs that I have in place, those APIs are constantly changing. So how do I get in front of that? Another big problem with APIs that organizations are struggling with right now is the fact that they are not adequately documented. So even if I know an API is there, I'm not quite sure in a lot of cases, what the purpose of the API is, or how it was actually developed, or what the blueprint of the API was and how it should be used. An interesting statistic that came from a Postman study in 2022 in their State of the API Security was that when they surveyed over 37,000 developers, only 3% felt that APIs were adequately or well documented. These are the developers who built the APIs who are coming back saying, I don't think we're documenting these well enough, so how in the world are we supposed to be able to get our arms around this and actually secure it? Another interesting fact with APIs is the fact that attacks are different than different attack types that we have been sort of programmed to get in front of and block and tackle in the past. One of the problems with API attacks is that the attack traffic masquerades as real traffic. It's hard to decipher and discern with the technologies that are typically used by organizations that are in place today, to be able to actually discern when someone is doing bad things against my APIs. And there's a few different reasons for that. In the past, we had predictable attack patterns where we had technologies like WAFs and gateways and bot mitigation technologies that are able to actually look for a particular known sequence, a pattern, or a signature and get in front of attack. Things like SQL injections, cross-site scripting, code execution attempts. We could do that, we could capture it, and we can block and tackle it. The problem we're seeing with APIs is that the attack types are very, very different. Reconnaissance may take weeks for an attacker poking and prodding against an API trying to find a vulnerability and a weak point. Also, the attacks are not grand slam, single swing and done attacks. They're typically logic-based attacks and multi-step based attacks. So what this basically means is if I don't know how an API is typically used, and my attack types are business logic focused, I don't typically have a technology in place in my web defense arsenal to be able to actually discern and understand when something bad is taking place against my APIs. So you may be saying to yourself, well, that's scary, but I'm just going to address this. I'm going to shift left, I'm going to focus there, and I'm going to do everything from a testing standpoint, and I'm going to flush all of this out in my development pipelines. But there's some real big limitations when it comes to automated testing. First, as I mentioned before, a lot of organizations don't have a very good grasp about the APIs that are even out there in the first place. What's that inventory look like? Do I have shadow APIs? Do I have a long list of zombie APIs that I'm not even testing or looking at anymore that we forgot to take down? And even if I know about the API, most organizations in their automated scanning are treating them like web applications. It's surface-based scanning on an endpoint and not getting down to sort of business logic permutations. With a lot of the studies that we've done with DevOps and DevSecOps experts in the industry, we typically see that the best organizations in the world are able to test at best 20 to 30% application logic permutation before an API goes out the door. Those are the best organizations in the world. So there's a whole heck of a lot we don't know about APIs, especially from a business logic vulnerability standpoint, when an API goes into production. So because of that, we have to assume what we're putting in production has some type of business logic vulnerability associated with it. And every business logic vulnerability essentially is a zero-day attack specifically to that particular endpoint. So at the end of the day, API risk, it's an inescapable production reality. We have to be okay with the fact that we have to love and embrace APIs, but we have to be okay with the fact that there is risk with this particular API first world, and I have to be okay with that risk, but doing so in a way that having a strategy in place to be able to mitigate a lot of the risk and the challenges that we talked about before. What does this all mean in terms of breaches that we actually see in the public or we see in the press that are getting announced? We've heard a lot about the OWASP API top 10, but breaches really come down to 4 different attack categories that we're typically seeing API adversaries. The first attack type that we typically see based on the challenges I talked about before is around lack of API visibility and governance. This is when an attacker is taking advantage of an API whose existence and security posture is unknown. I didn't know that API was out there, or I did, but I wasn't aware that its security posture was so bad. Or I made a mistake and I exposed something to the outside world. I have a lack of governance. I didn't know about it. An attacker found that API, and that API had weak authentication and no authentication, and I'm pulling sensitive data and exfiltrating data out of that API. Organizations are struggling, and the attacks that we're seeing are also around API abuse and misuse. This particular attack type, again, is a low barrier attack as well, because I'm not doing anything sophisticated as an attacker. I'm just using the API as it was designed, but in a nefarious or a malicious manner. So as a developer or as an API architect, I put this API out into the world. Let's say it's a microservice. It's functionally doing exactly what it's supposed to be doing, but I did not think of all of the adversary use cases that an adversary or a bad actor could use with this API. A great example of this particular attack type are attacks around data scraping, where an attacker gets in, or they are using an API as it was intended to be using, but they are pulling data in a manner that the API wasn't intended to basically supply. The most prominent attack types still that we're seeing out in the wild today are business logic flaw. These are those zero-day attacks based on business logic in each and every endpoint that you have, a unique endpoint that you have. And really, this is where a lot of reconnaissance comes in, poking and prodding against the APIs, where attackers are looking for the ability to produce some type of negative behavior out of the API by switching things up or poking and prodding, slight changes. A lot of these attack types, over 80% of them are schema compliant. So even if I have an OAS schema and I'm trying to do some positive security analysis or positive security modeling against my APIs, these attack types typically still get through. And a lot of times, attackers are taking advantage of something the developer left behind. A lot of it's debug code. If I do this, or if I poke here or prod here, that the developer leaves something behind that gives me access to either crown jewels or elevated access into the system that I maybe can actually then move, and traverse into my second stage of an attack. So again, this is still the primary attack type that we're seeing today in the wild. Lastly, is a more prominent attack that we're seeing become more and more popular, and a lot of our customers coming to us looking for assistance to solve, is this notion of stolen credentials and social engineering. Training my employees, don't click the link, it's too enticing, click the link. Somebody gets access inside the walls, now they have access to source code repositories or internal systems, or a low code, no code system with weak security posture on the inside that has access to all of our business data and crown jewels, but with without the right amount of security around it. Once they're inside the walls, one of the attack patterns that we typically see is attackers looking for privileged API keys in source code repositories internally. And then once they have access to a privileged API key, they're banking on the fact that organizations don't have the right defenses in place to be able to discern if that API is being misused or abused by an entity that has the right authentication and authority to use that API in terms of credentials. So we'll kind of shift the conversation here to sort of the second half of the presentation to not all bad stuff, but what can we do to protect from really around API security heartache? What's the relationship advice there? The first is really around education. It's important to understand how APIs are attacked, so you can not only proactively design, develop, and deploy more secure APIs, but you can identify when an API is under attack and conceptually know how to respond. On the SALT website, we have a lot of great resources around this, from based on the discussion today, an ebook around understanding API attacks, a breakdown and simplifying the OWASP API security top 10, including the new changes to the top 10, as well as mapping API attack patterns to a lot of known attack frameworks like the MITRE attack framework and NIST and other frameworks that organizations have already built workflows and run books against. So again, great resources there to get familiar with that. Once you have a good understanding of what it is from a risk standpoint and from an attack standpoint that attackers and adversaries are doing against APIs, you have to come up and embark on a strategy that's going to allow you to embrace APIs and continue to innovate and leverage the benefits of APIs without taking on the risk. And so today I'll walk through a strategy that is very effective of doing that. And it's a twofold strategy, a couple parts to it. The first is I need to quickly minimize risk without disrupting my ability to innovate. I need to be able to, as I mentioned before, embrace APIs, but not put security measures in place that are so abrasive and cause so much friction that it actually slows my business or disrupts my business or pauses my ability to run my business. And there's a couple things or a couple elements that are important when you take on this particular part of the strategy. And this is, again, the first phase of the strategy. The second phase of the strategy is this notion of I need to enrich the security ecosystem with API intelligence and API awareness. The fact of the matter is that API security, it's a strategy. It is not a single platform. There is not a single platform in the world, no matter how they market it, that is going to be able to solve all your and mitigate all of your API security risk. It is a team sport. It consists of a lot of different security disciplines in the API security ecosystem. The problem with that ecosystem right now is that there is not a lot of API layer intelligence that is shared with that ecosystem that will really give us that benefit of depth and defense. Or defense and depth, I should say. So from a risk reduction standpoint, what does phase one actually look like? How can I quickly minimize risk without disrupting my business? It all comes down to I need to build this notion of intelligence or API intelligence. And this is the discipline that here at SALT we have really mastered and proud to say that we're best in class with. And it's made up of a couple key different value areas and elements. The first is this notion of I need to discover all of the APIs or discover what my attack surface looks like from an API standpoint. I need to accurately identify that attack surface. I need to inventory it, understand how those APIs are used, the data associated with them, and I need to be able to have a technology in place that is trustworthy and can do this at scale. That's step one. Step two is, am I comfortable with what I'm seeing from a discovery standpoint? We need to understand, am I adhering to best practices from a security standpoint? What does my actual posture governance look like? And then take a step back and say, what is acceptable for me from a regulatory compliance standpoint? But internally, what are the standards that I want to set up so that I can make sure that when we're building APIs, that standard is enforced across the whole ecosystem, from a developer desktop to how engineers are configuring API gateways, to my identity service provider configuration, to my WAF configuration. So an example of a governance policy could be, I want to create a policy that says when someone leverages or uses a user ID in an API, it can't be in a guessable format. It has to be in UUID format. Great example of a policy there that I want to publish and enforce and share across my whole ecosystem. So that, again, is sort of step one, the discovery and the posture management, posture governance side of it. In parallel is really step two of this of the adaptive API intelligence phase here of the strategy. And that is this notion of throwing a safety net out so that I can cover a lot of the business logic attacks that I was talking about before. Right? Again, these are very, very difficult to flush out in your testing cycles. So I need some type of insurance policy that gives me the ability to understand when my APIs are being attacked, or if I have particular logic vulnerabilities in production already today. Now, this particular phase is typically done in parallel, but for a lot of organizations, this is typically the first phase that they take, because most organizations will know what are my API crown jewels today. I may not know everything that's in my API attack surface, but I know here are the 5, 10, 50, 100 endpoints that are key to my business. And if I have an issue associated with them, I'm going to feel some real pain. So a lot of organizations, again, the discovery and the posture compliance, very important, but a lot of organizations focus here first on the APIs that they already know that are important. Because how well do I actually know my APIs? I know that they're there. I know it has some authentication in front of it. I'm comfortable with some security, a lot of the security postures, maybe with those known APIs. But I don't know what I don't know from a logic vulnerability standpoint. I need protection there, and I need the ability to not just say, hey, there's an anomaly against an API from a behavioral standpoint, but I need the ability to discern when a malicious user is doing bad things against an API. With the advancements of machine learning and AI over the last several years, this has really, really been a game changer over here. It's the difference between getting flooded, if you do this properly or using the right technology, it's the difference between getting flooded with thousands of alerts a day into your SOC, or a mix of only a few alerts where the technology has actually been able to discern that, hey, this is not a developer who's having, where we're seeing some behavioral anomalies that's making some integration errors, when they're testing out a new API or integration into an API from a new system or a new service. This is actually a nefarious user who is doing some long phase reconnaissance against my APIs, and the intent of that user is malicious. Again, machine learning has really, really changed the game here, and has really given us in a lot of organizations the ability to, as I mentioned before, cast that net and give you the confidence that it's okay if I don't know everything about my APIs from a logic vulnerability standpoint. I have this insurance policy that I trust in production that will capture the bad before the really bad happens. So long-winded, but that's the phase one of this particular strategy. Phase two, as I mentioned before, is the enrichment of the ecosystem. I want to take this API intelligence and I need to make everything else in my security and API lifecycle ecosystem API aware. This ranges from informing developers on, as I mentioned before, what are the right things from a security posture standpoint you should be adhering to when you're developing APIs. This is taking runtime elements or runtime threats that are found in production and going back to the developers and say, hey, did you know that if a user goes from three digits on this particular parameter in an API to 4 digits, it actually causes a 500 backend, and this could be used for an application level DOS type of attack, a low traffic DOS attack. It is enriching everything else in the ecosystem as well, from testing technologies to API gateways to CDNs to WAFs. I'll talk more about this in a second. And again, the advantage here is that by giving and sharing this intelligence with the broader ecosystem, it empowers me to build a process and a program where I'm building and I'm producing more secure APIs. And it's also providing another layer that's giving me defense in depth in protecting my APIs across all of the different technologies and security tooling that I'm using today. And as I mentioned before, there's not one vendor that can do all of this. The ecosystem is made up of all sorts of different security disciplines and vendors, and organizations, to really, really reduce risk, have to take a best of breed approach here. We've seen organizations try to use one product or one vendor to kind of do everything. And from a risk reduction standpoint, they have not been successful. So again, this strategy is a strategy that we've seen organizations really, really have good success with from a risk reduction standpoint, and future-proofing a lot of the APIs that are coming through the lifecycle now and greenfielding into production. Now, when we talk about enriching the ecosystem and how this adaptive intelligence can be used across all of the other different security disciplines in your ecosystem or ecosystem lifecycle technologies, there are a few different elements here. I'm going to talk about just some of the ecosystem, some of the ecosystem technologies that the API intelligence can actually help enrich. One of them is the WAF. So having the ability to not just do the basic blocking and tackling, I see something bad, I want to tell the WAF, here's an API consumer to block. We also can do things such as identify where particular APIs that are supposed to be protected from the WAF are not actually behind the WAF. So that's intelligence that, again, we can change WAF configurations and API architectures there. We can take runtime learnings from this API intelligence and say, wow, it looks like I have a business logic vulnerability, but my application team is 1 month behind in terms of everything else that they have from a P1 standpoint that they're working on. I want to automate remediation to the WAF and tell the WAF specifically a behavior to look for, so I can create application level virtual patches to stop a particular behavior right now while the application team has this in queue to fix it and work on it. From an API gateway standpoint, intelligence helps a few different things. Again, it helps figure out what are transactions that are not going through the gateway, that we need to alter architecture. Is the gateway doing what it's supposed to be doing from a posture standpoint? From a lot of the digital transformation projects that I've been in the past, one of the big issues is we tell developers, you have 20 microservices you have to develop in the next 60 days, but don't worry about a lot of the security. We are going to abstract authentication, authorization, and a lot of that at the API gateway standpoint. But are we actually doing that at the API gateways? In a lot of organizations that don't have good governance in place and good intelligence in place are finding that the gateways are not correctly configured for what they should be abstracting and taking away from the developer. That has to be a cohesive relationship. The other piece is simply with rate limiting. I shouldn't just put a generic rate limit on my API gateway for everything. That may be good for back-end protection. But from a security standpoint, every endpoint has some type of unique business value associated with it. And the call frequency is going to be different. So I need to be able to take intelligence about how APIs are used so that I can dynamically apply security elements and configurations like dynamic rate limits more appropriately on the gateways. From a cloud security standpoint, this gives organizations the ability to have API-specific posture events and threat intelligence and give a holistic threat protection view in their cloud security technologies. From a developer standpoint, I talked about this before, the ability to share threat insights and vulnerabilities that are found in production back to your developers, but also help developers. That statistic I mentioned before that came from Postman about only 3% of developers feel that their APIs are adequately documented. Assist the developers here. Use this intelligence to be able to build documentation and populate developer portals with up-to-date documentation. Ensure that your APIs are not drifting from that documentation, and then respond with corrective or remediation measures back to your developers to fix. And the last is around testing and DAST. A lot of organizations are really trying to figure out in the pipeline, how can I get better about API security testing? Over the last couple of years, a lot of the DAST and IS providers in the market were not really focused on APIs. They were more focused on web application scanning. So the market looked to the API security vendors to basically say, hey, can we need something to scan APIs. Can you do it for us? At the end of the day, the API security vendors are not testing technologies. They're not testing companies. This is a particular security discipline that you have to have mastery in to not be abrasive and cause friction into the pipeline. This is a very, very important integration and a very key integration in that it's not just what you test, but it's how you test in terms of how you're integrated in the pipeline. And are my developers okay with using this particular tool? So this intelligence is very important from a testing standpoint. And there's a lot that we're actually doing to empower a lot of the testing technologies and enrich a lot of the testing technologies that are already out there today. So with that, before I go into a little bit more detail about that, I want to announce today at SALT, hit the press, blogs on the website, information up on the website. We actually announced a SALT Technical Ecosystem Partner Program. We call this the STEP program. This formalizes everything that I just talked about in terms of enriching the whole security and API lifecycle ecosystem with SALT API intelligence. The inaugural partners for this integration into this partner program are SAST and DAST providers, Bright Security, Invicti, StackHawk, Contrast. These are all technologies that are inaugural partners that we're enriching with API intelligence to be able to give them the ability to provide best-in-class API security testing. Again, we're providing intelligence to help them with the testing. They're providing the framework and the testing know-how and how to integrate into developer pipelines in a non-abrasive way to actually effectively test. We're shortly going to be formalizing this program with a lot of the other integration work that we've already done with WAFs and API gateways and cloud security providers, so be on the lookout for that. And as I mentioned before, on our website, salt.security, you can actually get more information about this program that we just announced today. So what is it that we actually announced today, and why is it actually important? This is, again, a fundamental difference in strategy and in an enrichment strategy that we believe is going to allow our customers and organizations the ability to test APIs better pre-production and capture more logic permutation flaw before APIs go out the door. So there's a couple things that we're doing with the partners I mentioned today, the Bright and Victi Stack on Contrast, is that we're helping those technologies identify what is the attack surface that I should be scanning from in the first place. Here are all the APIs that we see in the attack surface in your organization. What is DAST enabled and what's not? And from a posture and a data standard standpoint, or handling standpoint, what is it these APIs are doing and what are they ingesting and exposing from a sensitive data standpoint? This will help me prioritize what are the ones I should be DAST and IS enabling before the others. So that's step one. Step two here is, now that I've identified it, I need to know how to test it. I want to get beyond the fact that I'm just surface scanning a particular endpoint and treating it like a web application. I need to have some rich data that allows me to get deeper. I need to know how the APIs are used from a logic standpoint and from a parameter and data standpoint. What is it that they're sending and what is it that we're expecting to receive back? So one of the other things that we're doing with this particular integration with these partners is we're providing content-rich OAS specifications specifically for testing to these particular testing partners. Again, these are best-in-class testing frameworks that are developer and pipeline approved that a lot of organizations are already using in the market today, that now we are giving context-rich OAS analysis or specs to, so that I can get deeper and better testing against my APIs that are around my organization. The second piece of it is that we're giving organizations the ability to not just provide this data, but if I find an API I didn't even know about, it's used a lot, it's handling a lot of data, from an AppSec standpoint, it's just not onboarded into any of our security measures or programs, I want to be able to kick off and analyze something right away and run a test right from the Salt console. So with select partners, we implemented this right from our platform. So the workflow, again, is I see something, didn't know it was there, it's touching a lot of data I'm concerned about. I know from an AppSec standpoint, we haven't really looked at this. I need to be able to just do a quick validation, a quick scan against it. Again, having the ability to do that from a workflow perspective from our console is pretty powerful with the leading testing companies in the world. The other piece here is this notion of managing posture. Once I have a posture rule and I've documented a posture rule, something that I'm assessing, as I mentioned before, a user ID that has to be a UUID format, those posture assessments and those rules can be shared with the testing platforms. So now again, I'm not just running known tests and logic tests, but I'm actually assessing what is it from a posture compliance standpoint that before I was really just looking at in production and staging. I now can capture that right as developers are building applications or they're building their APIs inside the pipeline. So again, sharing that posture, those posture rules is very, very important. And the last piece here is this notion of, if I find a vulnerability in production and I see some type of negative behavior, I don't want to make that same mistake over and over again. I want to be able to actually get that behavior, see that particular negative behavior or vulnerability, and I want to add that to my test cases. I want to make sure I never see this particular attack type or negative behavior or vulnerability find its way into production again. So again, that's the ability to take this runtime intelligence and runtime findings and be able to share that with the testing technology so that, again, we're enhancing their test cases and their testing capability to capture a lot of the API attacks and attack behaviors and campaign types that we're seeing today. So really, I'm going to walk through sort of the last couple of minutes of the presentation here. I hope this was helpful. I'll stay on for a couple more minutes here and we'll talk about, happy to answer a few questions for you. A couple of things I just want you to walk away with this presentation. You folks know this already today. APIs are powering all of our modern apps and digital supply chains. APIs exist where you don't think they exist in a lot of cases. If you have a new web application, there are APIs. If you're working on a mobile application, a new mobile app, or updating a mobile application, there are APIs. If you're integrating with partners, there are APIs. A lot of the greenfielding that we're doing, if you hear the word Kubernetes, and as where you're running workloads, you have APIs. So again, it's important to realize that APIs are all over your organization. And if you're not effectively accounting for them, addressing for them, your applications are not secure, and essentially your business is not secure. And the last key piece here is that realize and recognize that API security truly is a team sport. There are a lot of different security disciplines that are involved in reducing application risk or risks to your business. The issue with a lot of the different disciplines is that they did not have a lot of API awareness and API intelligence enriched inside of them. And that truly is where SALT comes in. We see ourselves as the industry-leading platform for that API intelligence that will give you the ability to enrich your whole ecosystem and ultimately give you the ability to produce better, more secure APIs in your application ecosystem. On our website is a lot of everything that I just talked about today, from videos to ebooks to information and other posts from our Get Smarter About API Security campaign that we recently launched. So I invite everybody to go to salt.security to capture a lot of that data and download. That said, I will stay on for a few minutes here and see if there are any questions from the audience that I can help answer.
Thanks, Nick. It looks like we've got a question from Trevor. His comment is, the big thing we find is the amount of APIs using basic auth, even from external security vendors and no support for OAuth. And if that's one you can tackle. I know we've done some of our Salt Labs research around OAuth.
Yeah, it's a good question. So there's kind of two elements to this. The first element is APIs that you are producing yourself, Trevor. One of the important elements from a posture management governance standpoint is you may say that, hey, if I have an API that I'm producing or that I'm exposing or responsible for, I need to make sure that if it's handling sensitive data and external, it's using OAuth and maybe OAuth with a particular signing algorithm. Using Java with a particular signing algorithm. So that's something that you should be able to put in place and assess and make sure that if an API is not adhering to whatever that posture standard is that you're setting in your organization, that you'll be able to capture it and then remediate that. Leveraging third-party APIs is a problem for a lot of organizations because you're at the mercy of whoever and whatever the entity is that's actually producing and exposing that third-party API. One of the things that a lot of organizations have done is a new API pattern where they're going to their third-party partners that are providing these API services and API integrations that your supply chains or your business processes are relying on, and they're going to them and saying, listen, I want my data to come from I want the data to your API or the integration with your API to come from my API gateway. Is there any way you can lock down from an IP standpoint, even if you're only doing basic authentication? Is there any way that I can put a control in place that will lock down that the communication to your API from my organization has to come from my API gateway? What that will do for you is it will shrink the attack surface so that even though it's basic authentication from you to them, you're locking down so that that basic authentication can only be used from IPs that you trust. And the more general usage of that API will be through your API gateway, where you can enact any API authentication scheme that you want. So you can then say, here, anybody internally, even external partners that leverage this, that ultimately goes to the third party, I'm now enforcing that it's OAuth. So I hope that answers the question. That is a API pattern that we're seeing with a lot of organizations right now who are really going to their third parties and saying, at the very least, I need some type of ACO on IP so that I can put some type of control and visibility in front of the API that you're providing.
Great. We also had a question from Kamal. Are the regulatory bodies and compliance frameworks starting to pay attention to API security yet? I know we recently saw the OWASP API Security Top 10 get updated. What about some of the other frameworks? What are they doing around API security?
Yeah, OWASP API Top 10 was really good for sort of fleshing out and educating what are the different vulnerabilities that we see with APIs. But from a runbook, workflow, and a program standpoint, a lot of organizations really lean on NIST and MITRE and other frameworks that are out there. The good news is that a lot of the frameworks have taken notice to APIs. While they may not have formalized particular API briefing, we're seeing that organizations such as us are taking it upon themselves to do that mapping, and a lot of that mapping is being well received and actually utilized by the frameworks themselves. So I think you're going to start to see that change. We're already seeing it from a compliance and regulatory standpoint, we're already seeing this notion of APIs start to come into focus and be called out rather than just assuming everything is a generic web application. So some TBD there, but we are seeing a trend that a lot of the frameworks are really focusing on APIs going into next year.
And to brag on Nick a little bit, we do have a couple white papers and resources around some of the frameworks like MITRE, and one coming out very soon on NIST, kind of around API security and how that mapping can be done. We have another question from the audience. Should an organization's API be behind an API gateway?
Yes, 100% every time. No doubt. From a governance standpoint, you need to have one place or one technologies. And I know that's hard. A lot of organizations, we have multi-clouds with multi-API gateways, but a best practice for a lot of organizations is really to try to facilitate that everything go through an API gateway standpoint. One of the major reasons from a governance standpoint is I have ultimate visibility and control over how APIs are exposed to the outside world. But not only that, we rely on API gateways to do a lot of abstraction, especially some security abstraction that we take away from the developers. So one of the big problems is if I have 5 different API endpoints, all of them are OAuth authenticated, but I don't have an API gateway in place. It's the responsible of the developer in those cases to make sure they're all implementing OAuth the same way with the same libraries and the same manner. All of this can be abstracted to the API gateway. It really, really makes things easier and allows you to embrace APIs in a much, much better way. And as a frontline security element, APIs do a lot. Again, from a visibility, governance, control standpoint, that helps. But basic blocking and tackling of rate limiting, authentication, and authorization, these are elements that are important that you can standardize on the API gateway. So all day, 100%, yes, API gateways are important.
Okay. And this next question from Adrian is related as well. WAF and API gateways, are they better integrated or separate solutions? Kind of what have you seen in kind of best practices? There are some vendors that do both and some vendors that specialize in one or the other.
It's a great question. From my standpoint, these are 3 different security disciplines. So when we talk about API runtime security, when I talk about a WAF and WAP technology, and when I talk about an API gateway, they all serve distinct different purposes. So I'll give you a great example of that. From a WAF WAP standpoint, those are inline technologies that are analyzing traffic. They are your frontline edge defense, and they're looking for known security, known attack patterns or signatures to do that basic blocking and tackling, right? They are not architected to be able to do the really heavy lifting when it comes to business logic attacks. That is a whole different monster and a whole different architecture and technology, typically that only can be done with asynchronous security, where I'm using big data and cloud compute and machine learning to really understand when someone is doing bad things against my API from a logic standpoint. So they're complementary technologies. Now, there are certain things WAFs and WAPs can do from schema analysis and positive security modeling, but again, 8% of API attacks we see will get through that particular defense. So I need to have sort of that big data element of security to capture and give that security net I mentioned, that insurance policy that I talked about before. So I feel comfortable that I have some coverage against what I don't know about my APIs out there. I just talked about the sort of the API gateways and what their discipline is. And again, they have a sliver of security as well. And again, that's why I mentioned before that really is a team sport. There are all sorts of different technologies in the ecosystem that all have a slice and a responsibility for security, but they also have slices and responsibility for other elements of API management, API governance. So it's important that they all share the same intelligence and work together in harmony, because at the end of the day, how I develop an API is probably going to be dictated based on how an API gateway is configured and what's abstracted to it. So again, it's important from a posture standpoint that that information is shared across the whole ecosystem and with the personas that manage each and every one of those technologies.
I think this one kind of, maybe you've addressed some of it, but Trevor asked, are there any advantages of an API gateway over a standard firewall load balancer if the app handles its own authentication properly?
Yeah, that's probably a longer conversation, but as I mentioned before, there really is major differences between what a WAF does. I mean, a WAF is not made to be your routing engine for APIs at the end of the day. That's not its primary purpose. So again, from a feature function standpoint and what an API gateway actually gives you, it's going to far extend that of what a WAF and WAF can actually do. Again, I talked a little bit about that already before, but again, also a conversation I'm happy to have offline so we can talk a little bit more about what are the key differences. And again, from a responsibility standpoint, why do I even have an API gateway in the first place?
Okay. Then we had a question from Charisse. If an organization has a flat network, what is the best setup for public-facing APIs? That's...
If an organization would probably need a little bit more information about what they mean by flat network. So, Charisse, if you want to put a little bit more information, and we'll come back to that question.
Okay. Okay. All right. And then the last one we got, and this we get quite often from Amy, my colleagues think attacking APIs is rare and difficult. How do I explain the hackers are doing this today? No, there's a lot of what you talked about today, but how do you raise the flag and say this is happening? And here are some examples of what's happening.
Yeah, that's a pretty easy one. I mean, obviously there's statistics that show that API abuse and attacks are on the rise. Just from our own reports, our State of API Security report that we recently released, some of the metrics from our Salt Labs team is a 400% increase in API attacks over a 6-month period that we saw in Q1, going into Q1 of this year. But it doesn't take much to go on the web and search for API attacks or scraping breaches or data breaches. And you will see a lot of the attack types and a lot of the breaches are not very sophisticated. Like I mentioned before, because of the challenges around sort of lack of control, sprawl, the barriers to sort of flushing out logic flaw and testing, and just a lot of organizations not having the right runtime security elements in place to capture bad behaviors, the barrier to breach is pretty low. So I would argue that one of the most appealing things about APIs from an adversary standpoint is a lot of cases all it takes is a postman or an Insomnia REST client, and I can poke and prod, do reconnaissance, and probably find some type of logic vulnerability and write a script to exfiltrate data and sort of masquerade as real traffic. So again, it is a very low barrier to breach.
Okay, perfect. And Charisse, to clarify, flat network, only one network system for the entire organization. But we can. I think the nice thing about that, Charisse, is it makes life a lot easier for you. It makes life a lot easier. If the question around is what's the basic setup for public-facing APIs, if it's around security, one of the nice things about having that flat network is, to do a lot of the things I was talking about today, it requires the ability to actually inspect traffic. Right? I need to read request response data, extract metadata from it to basically understand how APIs are structured, postured, how they're used, structured, and behaviorally what's normal about their usage. With a flat network, as you're describing it, your choke points are pretty simple, right? So I can go to my incoming CDN, I can go to my API gateway, I can go to my my load balancers, I can go maybe into my workloads. If we have a unified and everything's running in one Kubernetes cluster, I can go there to capture the data I need to do this. So it really, really simplifies the implementation on that sort of first phase of that security strategy I mentioned before. We're kind of casting that net to create that insurance policy. Okay, perfect. All right. Well, we want to make sure you've got a couple of minutes at the end of the webinar here for you to get to your next task today. But I wanted to thank Nick for sharing his deep expertise in API security. If you have an API security project on your radar, we'd love to show you the SALT platform in action. As a reminder, there are some resources on that right side of your screen, including an ebook on understanding API attacks. If for some reason you miss it here, it's also available on our website. We also have a great blog. There's a ton of content. Nick is one of our contributors, puts out a lot of great content there. You can also subscribe to our blog digest. We send you a digest of what's been posted in the last couple of weeks, every 2 weeks. So we appreciate you spending a part of your busy day with us and look forward to connecting with you again soon. Thank you again, Nick.
Thanks, everybody. Thanks, Tim.